Okay, so 1.2a, we are talking about real numbers, okay? We will talk about imaginary numbers in chapter 4, but we're going to focus on the real right now, okay? Yeah, we'll get there. But real numbers get separated into two different categories, one of which is rational numbers. Anyone know what the other one is then? Irrational, yes. And I appreciate the hand raising. You don't need to. You can just speak it whenever you know it. So rational and irrational numbers are the two main categories that we'll be working in. But then underneath that, there's all these other types of numbers that we'll focus on as well. So one thing to note, if it's a real number, it can be plotted on a number line. So if you're ever like, is that a real number? Is pi a real number? I can put 3.1415 blah, 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 on a number line, right? Anyone know that to an obscene number of digits? Pi? Yeah, me neither. Someone in my last class had 20 digits. He said he got bored in his math class, so he memorized pi. Okay, so if you can put it on a number line, it's a real number. Real numbers, I'm going to give you letters that represent all these things. So real numbers kind of looks like the paragraph symbol, but it's an R instead of a P. When you see that, it means real numbers. Okay, and I'm just going to go down the line right now and give you all the letters, and then we'll talk about each one. Rational numbers, because there's an R here and an R here, we can't use an R, so they use a Q. No idea why they use a Q, but they do. Excuse me. Natural numbers is an N. Whole numbers is a W. Integers is not I, because irrational is I. So this one's I. Integers, anyone know what it is? It's a Z. I don't know why, but it's a Z. Okay, so if you see those letters, they're representing that number group. Okay, so let's start with rational. The rational numbers, there's a few qualifiers for rational numbers. One is they can be written as a fraction. Okay, so for instance, A over B would be considered a rational number. If you can write it as a fraction, it is rational. If you can write it as a terminating decimal. Do you know what a terminating decimal is? It ends, yes. So a terminating decimal would be 2.75. So if you can write it as a terminating decimal, it is a rational number. If you think about that, 2.75 is 2 3/4, right? So it's a fraction still, but they're giving it to you as a decimal. And then the last thing, if it's a repeating decimal. So that would be 2.6 repeating, right? That's 2 2/3, 2.6 repeating. When they put that bar over it, that's a repeating decimal. It means 0.666666666, so on and so forth. So that makes for a rational number. You can write it as a fraction or a terminating decimal or a repeating decimal. Then under rational numbers, there's 3 different subcategories. There's natural, there's whole, and there's integers, okay? And they're very similar. One actually has all the others in it. Does anyone think they know what the natural numbers are? I always say, if I were naturally going to count to 10.
Oh, 1, 2, 3, 4.
1, 2, 3, 4. You start at 1, right? So the natural numbers are the counting numbers. Counting numbers. So 1, 2, 3, 4, and so on and so forth. Okay, those are the natural numbers. Anyone know what difference there is with the whole numbers? 0, right? I always tell people, look at the word whole. There's kind of this 0 right in the middle of it. So it's the counting numbers and 0. Okay, so that would be 0, 1, 2, 3, and so on and so forth. Okay, so the counting numbers and 0. All right, and then the last subcategory of rational numbers here is the integers. Who can tell me what integers are?
Negative and positive.
Negative and positive. So it's the counting numbers and their opposites. So the negative version of it and 0. Okay, so that would be -2, -1, 0, 1, 2, in both directions, right? Keep going in both directions there. Okay, so those all fall under rational. What's an irrational number? Can anyone give me an example of an irrational number?
Pi.
Pi. That's the most common irrational number that you hear of, right? People think irrational and they think pi. So irrational numbers, these are basically if you take the definition of rational and you say not to all of those things, that's your definition. So it's the decimals don't terminate or repeat. Okay, and cannot be written as a fraction. Okay, so one great example of that is pi. Anyone think of another one? I think the other most common are square roots that are not perfect squares, right? The square root of 2 is an irrational number. If you plug that into your calculator, I don't know what the number is, but it's like 1.12654. There's not a pattern to it at all. It's just this number that keeps going, okay? So that's irrational. Okay, so we're gonna just talk through 4 examples of this and then we're done. The first one says the school, it's supposed to say has, but it says as. School has a cross-country team. Which set of numbers does not contain the number of people who are on the team? So which one does not contain the number of people on the team? What would you say? Natural, integer, rational, irrational? Irrational, right? You cannot have pi people on the cross-country team. You can have a natural number, 3. You can have an integer, 7. You can have a rational number, 600, right? You cannot have an irrational number of people. Okay, so example 2 says, if each person on the team had to pay this fee, $175.50, circle the one set of numbers that best describes the situation. Best describes, okay? It's not that there's one answer, but what's the best answer for this? So you want like the most specific you can give. Is 175.50 an integer? Integers have to be whole numbers and the negative version of the whole numbers, right? Not irrational would be not a terminating decimal. It is a real number, okay? Real is correct, but rational, I hear several people saying rational. Rational is the best answer, right? Because rational can be written as a decimal. That's what we have here. So this is a rational number. Yes, it is a real number also, but real is so broad, right? An integer is rational. Natural number is rational. We want the most specific one that we can give, okay? The best, in other words. Okay, look at 3 and 4. I want you to try those on your own real fast, and then we'll come back and do them together just to make sure we're good. Okay, tell your neighbor what you put for 3 and 4, and if you have different answers than them, convince them why your answer is correct. All right, what'd you put for number 3?
Irrational.
Area of a circle. Why irrational?
Repeat.
3.14. Yes, pi, right? The area of a circle involves pi, and pi is irrational. So that's going to be irrational. How about number 4?
National.
Oh, I hear different answers. Natural. Okay, convince me why natural.
Because you can't have 0. Well, wait, you could.
Oh, could you have 0 people in my classroom? Multiple times today I've had 0 people, 0 students. You can't have negative, right? So integer doesn't work, but what does? Whole, right? I can have 0 students in my class. Okay, so here's the deal. Is natural a bad answer? Not really. I mean, I could have 1, 2, 3, 4, 5. I could have those people, but it's not the best answer, right? Because I could have 0 people, 0 students in my classroom. Okay? So really stop and think about, what does that mean when you're thinking through the numbers? Yeah.
Is real a bad answer?
Real's not a bad, it's a correct answer. It's just not the best answer. So on a test, it's wrong. Yeah, because I want the best answer, right? What is the best answer you could give?
Just integers can't be in it.
Right. Yep. Any questions on any of that?